Hello, everyone. Good afternoon, and thanks for joining us for today's webinar, sponsored by the California Fire Science Consortium and the U.S. Forest Service Pacific Southwest Region Ecology Program. So our 2-hour webinar today will include perspectives from 5 different speakers about the outcomes from the 2019 Caples fire. We'll start with an overview of the Caples Restoration Project from Becky Estes, then learn about the volunteer program to prepare legacy trees in advance of prescribed fire from Lubetkin. Then we'll learn about the Caples fire management and facilitated learning analysis from Thane. We'll stop there for a few minutes to have our first time for questions and answers from our first set of speakers. And then we'll have a brief intermission so you can go run and check your email or whatever you need to do, stand up for a couple of minutes. And we'll also be playing a video and photo montage during that brief break from the Caples fire. After the break, we'll return for presentations about the ecological effects of the Caples fire from Dailey, and a discussion of the Avian response to ecological restoration in the Caples Creek Watershed from Durrell, Kapan. Lastly, Becky will come back and recap for us and bring us back to the big picture, and we'll have some more time for questions and answers. So without further ado, let's get going. Our first speaker today is Dr. Becky Estes. Becky has lived in Placerville, California, and served as a USDA Forest Service Central Sierra Province ecologist for over 10 years, working with the El Dorado, Tahoe, Stanislaus National Forests, and the Lake Tahoe Basin Management Unit. Prior to working in the Sierra, she worked as a postdoc with the Pacific Southwest Research Station in Redding, California, where she was able to work with a number of research scientists studying questions throughout Mediterranean climates. She did her PhD and her master's at Auburn University in Alabama. She completed her PhD in forestry there in 2006, and she now assists forests with a number of complex management needs in the province and region, including the importance of managing post-fire landscapes to ensure future resilience in the face of a changing climate. So Becky will be providing an overview of the Caples Restoration Project, and I'm going to pass the presentation over to Dr. Becky Estes.
All righty, so hopefully everybody is seeing the presentation and everybody can hear me. Thank you so much for the introduction. And thank you everyone for joining the webinar. It's really great to see people from a variety of locations as well as different management responsibilities, and really interesting to see everybody's responses to some of the poll questions. So we really appreciate your interest in joining us for the discussion today of the outcomes of the 2019 Caples fire. So to begin with, I just wanted to provide you with some background on the project and its development so that you have a better understanding of the objectives for this landscape. Okay, I'm having some slide changing difficulties. Has the next slide shifted for you yet?
Not yet.
There we go.
There it goes.
Okay. All righty. So the Caples Creek watershed, of which the 2019 Caples fire was within, is located in the Sierra Nevada. It's just east of Sacramento and west of Lake Tahoe. So if you can see in that upper left-hand panel, if you can see my pointer, there's an overview map, and you can see where the Caples fire was located, and the Caples watershed is surrounding that. So the Caples watershed is a 6-field watershed located about 30 miles east of Placerville, for those that know where Placerville is. It's about 20,000 acres in size and is part of the larger South Fork of the American River watershed. It's a really important watershed since it provides a primary water source to about 110,000 people. And so this watershed was an important focus area on the El Dorado National Forest for restoration. So I do just want to point out in the right-hand panel here, which we'll talk about later in some of the presentations in the second half of this webinar, is the Caples fire vegetation fire severity map. And so this map essentially shows us the impacts of the fire on vegetation. And so the ranges are from minimal impact, which is the dark green area, and the light green areas in here, to a maximum or high vegetative fire severity, which is in the dark red. Okay, so the watershed is also important as it has a wide range of ecosystem diversity. We have meadows in this landscape in the upper right-hand panel and the lower left-hand panel. We have aspen in the upper mid panel, chaparral, the lower mid panel, large legacy trees, which Lester will talk about shortly here, and you'll see a lot of images of them, and a range of other vegetation types from Sierra mixed conifer at the lower elevations to lodgepole and red fir at the higher elevations. Another really important component of this watershed is that it's roadless. It does have a trail system that runs through it, and it's regularly used by recreation. And so because of this, there's been minimal impact from past management in this landscape. Although there was little management in the watershed as far as timber removal in the early 1900s, late 1800s, fire exclusion is certainly evident over the last century. So this landscape, particularly in the mixed conifer vegetation type, would have historically had a mean fire return interval of every 11 to 16 years. And this is evident in the fire scars that are common across this landscape. So you can see in the image here on the right, a fire scar in a pine. And these are pretty common across the landscape, as are the large legacy trees. So if we compare this to the map on the left here that shows the fire return interval departure, you can see that at the lower elevation, sort of this western portion of the watershed, we have high departure, which is shown in this dark red color. And then in the higher elevations, and I will just point out in the higher elevations here, which we'll see some photos of this throughout the presentations and then also in video footage, there's sporadic vegetation with granitic rock features. So vegetation isn't as continuous there as it is in the western portion of the landscape. And so up here, where we have red fir and lodgepole pine, we have a more moderate departure from fire return interval. So all of these reasons that I've mentioned and many more reasons point to the importance of prioritizing this landscape for restoration treatments. And because we went through a planning process for this project, in order to better understand the conditions across the watershed, we looked at a variety of stand variables and quantified them and then compared them to the natural range of variability, so that we could really understand the degree and the direction of departure to better guide restoration targets across this landscape. And so I'll just briefly describe this table. So on the left, we have stand variables, and then we have the natural range of variability. We have Sierra Nevada wide, and so this is the metrics represented for all Sierra mixed conifer forests across the Sierra Nevada. And then we have just the Caples Creek. And so if you can see here, for an example, tree density or trees per acre is highlighted in red. And so this indicates that it has departed from the natural range of variability in the positive direction. So in other words, we have more trees per acre on the landscape in our current conditions. And then one more thing that I'll point out, which was really important in helping us develop targets for the prescribed burns, is our fuel conditions across this landscape. And you can see that the fuel conditions in the Caples Creek watershed are much greater than what they would have been in the natural range of variability. And so this information, which we'll talk more about in the second half of the webinar as we look at some of the implications following the 2019 Caples fire, was really important initially for planning because it helped us support the further need for restoration in this landscape. So from all of this planning work, the Caples Creek Restoration Project was developed, and there were a number of key objectives that are listed here over on the left: the improvement of watershed and forest health, the reduction of hazardous fuel accumulation, meadow restoration, the improvement of conditions for aspen and oak, and the improvement of public safety. And so I'll just briefly point out the treatments within the Caples Creek Restoration Project. And I will note that a decision memo was what came out in 2016 that approved the prescribed burning on 8,800 acres. And so you can see from the map here that about half of those acres were located in this western portion of the watershed. And so the focus here was understory burning. And then the other half in the upper elevation portion of the watershed, was vegetative island burning. And as I've mentioned before, in this portion of the landscape, there's not continuous vegetation. There are these vegetative islands, and you'll see a little bit more of that in some of the video footage. And so a lot of work went into preparing for the prescribed burning that was planned within the restoration project. This included pile burning, infrastructure protection, vegetation removal, particularly focused in areas of where legacy trees were common. And we'll hear more about that momentarily. And so all of this preparation and then some of the initial prescribed burns sort of led up to the transition to the 2019 Caples fire, of which Travis will walk us through in discussing the Caples fire management and facilitated learning analysis.
2 minutes.
All right, so there's one more thing that I just want to point out, and which was another big component of the Caples restoration project, and that is the monitoring and research that's occurring within this landscape. And I think because it was a large landscape scale prescribed burn, and we did some considerable planning within this landscape, it really allowed us the opportunity to establish a monitoring network and strategy so that we could really understand and track the changes in this landscape post fire. And so I'll just point out really quickly, just so that you can see sort of the diversity of information that's being collected in this landscape that we'll hear a lot more about in the second half of the webinar. So we have mixed conifer plots, which are located in blue, and those are co-located with the avian and biodiversity monitoring plots. And then we also have some monitoring that's occurring in the higher elevation red fir vegetation as well. And then, as I pointed out, aspen is dominant in this landscape, although because fire exclusion has been so prevalent, a lot of those aspen have been overtopped by conifers. So we were really interested to see how the restoration treatments, including the fire, will impact the aspen. And so, as I mentioned, we'll hear more about this in the second half of the webinar. So now I will pass it back over to Allie to move into our next slate of presenters.
Great, thank you for that great presentation, Becky. A reminder to type your questions into the chat box at any time, and we'll keep track of them and have them answered during our Q&A sessions. Our next speaker is Lester Lubetkin. Lester coordinated the organizing and directing of volunteers along with staff from Sierra Forest Legacy. Lester is a Conservation Committee co-chair with the El Dorado chapter of the California Native Plant Society and is active in volunteer projects on the El Dorado National Forest. Lester will be discussing the volunteer effort to prepare legacy trees prior to the Caples prescribed fire. So you can go ahead and start screen sharing now, Lester.
Great, thank you. Thank you very much. And yeah, thank you, Becky, for the laying out what's been accomplished. As Becky described and as Allison described, I'll kind of go through a little bit of what the volunteers did. And I have to admit, I came in a little late, that there was a lot of work done by Sierra Forest Legacy, staff from there, and from the fire restoration group, and that really set the stage for the role of volunteers.
Lester, can you try and speak up just a little bit?
Oh, will do.
Thank you.
One of the things that and as was described by Becky, there was quite a bit of ladder fuel and vegetative material around the legacy trees there. It was recognized that was going to take a lot of just hand labor to address that, try and protect those trees so that the prescribed burn wouldn't be killing the large legacy conifers as well. And so it was recognized that it was a spot where maybe some volunteers and general public could assist with dealing with trying to reduce that the fuels around those legacy trees and help to make it so that the prescribed burn would be more effective and not as damaging to the legacy conifers out there. And so I got involved when they actually started to prepare for the some of the prescribed burn work. One of the first things that was done was there was mapping of areas where there were concentrations of those larger conifers, the legacy conifers, so that we could start to lay out how to even best coordinate and bring volunteers out to work on those trees. So, and then the other part was obviously getting some good training. We had 10 volunteers that went through a weekend of chainsaw training to really kind of make sure that people were going to be able to do the work in a safe and appropriate way. And then in late June, we had a weekend where those 10 volunteers worked with the Iron Mountain hand crew from the El Dorado Forest in removing ladder fuels and some of the large woody debris that was at the base of the trees to start, again, just helping to prepare. And have to also mention that the ACE, or the American Conservation Experience crew from there, was also doing some of the work, and Generation Green helped later in not with the chainsaw work, but some of the other raking and whatnot that was done. And then the third was a support from the California Wildlands Grassroots Fund with the Rose Foundation, that they helped with a grant for purchasing safety equipment and some of the tools for volunteers to work with. So I'll just kind of show, get a sense of that we had a range of different volunteers from various interest groups within the area that came out and worked with the hand crew, and we got involved anyways in quite a bit of variety of different types of work and removing some of the down material and also picking out what needed to be cut out. And also we had some assistance from the Elegant Ears Mule Club, which helped to pack in some of the equipment to some of the further locations. As Becky mentioned, it's a roadless area, and so bringing in chainsaws, water, some of the other tools that were needed. One of the things to describe was, when we heard, well, we're going to be trying to pick out the legacy conifers and raking and clearing the ladder fuels around them. But how did you pick which trees you're going to focus on? And Dana Walsh, the silviculturist, had suggested that as you walk around, you'll see some large conifers that are really beautiful, but then you'll come around the bend and there'll be just a beautiful, large tree. And the first thing you'd say is, wow, look at that tree. And so we were told essentially look for the wow trees, and those are the ones that we would really focus on, particularly the ponderosa pine, a little bit the sugar pine, because they tended to drop their needles and shed bark, and you'd get a large apron of material around the base, and also the ladder fuels around them. So just a sense of the volunteers working closely with the hand crew, but most specifically while we were doing the chainsaw work, just from a safety standpoint and being able to respond. So the next stage was actually the raking and more of the direct hand labor. We had 11 different volunteer days during the summer of 2019. We had over 50 volunteers that came out to rake duff and move some of the ladder fuels around these large conifers. Here you can see folks setting up and pulling away that large apron of vegetative material that was at the base. One of the things to watch for was that some of the conifers would have their small roots up near the base within that apron of debris, and trying to avoid damaging those roots. We had a range of ages of folks, and folks generally really appreciated getting to get involved, kind of felt an affinity towards those specific trees that they had tried to work with and protect. In this picture, you can see some of the, I'm pointing to some of the small stumps of some of the ladder fuel that was there that had initially been removed. We really wanted to keep the chainsaw work separate from the raking, so that just, again, from a safety standpoint. And again, the Allegheniers Mule Club was able to assist with bringing tools up to some of the farther locations. And it was, again, as I mentioned before, both hard work, but rewarding when you had finished. One of the other features to be looking for, and Becky mentioned the numerous fire scars, and that those can be, with the prescribed burn, and in particular the ground burns, if you get the fire into those burn scars, you can then start to further damage the trees and increase the loss. So that was one area that we tended to focus to really make sure that we had addressed it. Well, one other feature that was out there, it's the westernmost pinyon pine on the El Dorado forest, happened to be within the area of the Caples prescribed burn. So a group of us, 5 folks, went up to rake and clear some of the limbs and ladder fuel adjacent to that one pinyon pine, and so we were able to provide some safety measure to that. And actually, from what we understand, when the fire crew went up there later, that the tree had survived. So just kind of quickly summarizing, there was, as I mentioned, 11 work days, 68 volunteer days, because some of the folks did come for multiple days. We raked and treated about 200 trees over nearly 100 acres. And you can see a wide range of different groups that got involved in it. We put out notices through various different groups in the area, and had a wide range of folks that got really excited about joining us. And not on the list, but again, is the ACE, the American Conservation Experience, and also Generation Green, which is a high school students that helped with projects out there, and mostly, again, the raking. And so folks were eager to come back out again and help with future projects. Thanks.
Great, thank you, Lester. Our next speaker before our first question and answer session is Travis Thane. Travis is the District Fire Management Officer, Division Chief on the Placerville Ranger District of the El Dorado National Forest. He's been a firefighter for 23 years, working on engines, crews, helicopters, and on a Type 1 incident management team. He's been a Type 2 burn boss since 2011. And Travis will be presenting on the Caples Fire Management and Facilitated Learning Analysis. Go ahead, Travis.
Hey, good afternoon. I just want to make sure you're seeing the right screen. You're not seeing my notes.
Nope, looks good.
Okay, well, thank you for having me. I appreciate it. It's a pleasure to be here. This first picture is from Maiden's Grave. It was at about day 6 or 7 after the initial piles were lit. So you can see pretty much the whole prescribed burn from there. I'm going to talk a little bit about shared leadership perspective. I'm going to discuss the facilitated learning analysis, and then highlight some discussion and key points, and try and fit it in a quick 10 minutes. So from a leadership perspective, risk.
Travis, hold on just a second. It looks like the Zoom might be off. We're not seeing the right third of your screen. I don't know if that's.
Got any better?
If there's a Zoom window of videos, you could move it off of that particular screen and it probably will give us the full one.
How's that?
Go forward a slide just so we can check. Oh, and then switch to the presenter or the other view. There, that looks right. Sorry about that. Go ahead.
Apologize for that. I'll try to keep going quickly. But from a leadership perspective, risk with land management and firefighting, it involves complex decisions and exposure every day. Restoration, we're creating healthy forest after decades of fire suppression, and some unintended outcomes are expected as we increase pace and scale. We're definitely a learning organization. And the intent is of a purpose of with a declared wildfire review is to prevent unintended outcomes on future projects and to facilitate learning. Safety is a core value for all of us in the agency. And it's important to note that no major safety concerns were identified during the wildfire review. And FLA is part of all declared wildfires. It's required by interagency prescribed fire policy, and it recognizes that risk is never absent, and we must continually adapt and make judgments to handle emerging risk. With an FLA, leaders can see while accidents are very rare, risk is never absent. Employees are limited perspectives are continually adapt and make judgments to handle emerging risks. And these adaptations will never be perfect. Errors, mistakes, and lapses are commonplace. With our learning organization for the last decade in the FLAs, it's a process to help us learn from unintended outcomes with the goal, to create a culture that sees unintended outcomes as a valued learning opportunity and also a way we can reduce uncertainty for future outcomes. It's not designed to assign blame, and it creates a barrier which would create a barrier to learning that is essential to improving safety. It's externally reviewed by a peer review team. It includes forest supervisors, safety managers, FMOs, and fuel specialists from across the agency. So I'm going to talk about our specific FLA. If you would like to read the whole FLA, it's posted to our lessons learned website. If you just Google Caples Escape Prescribed Fire FLA, it comes up right away. A couple things to note with wildland fire, there's only two recognized kinds of fire within fire management policy, and that's prescribed fire, which are planned ignitions, and wildfire, which is unplanned, which can be human caused or naturally occurring. A little bit of background, Placerville was leading the project within the Caples restoration. The overall plan was to start at the top of the ridge and work our way down. We had a 50-foot fuel break all along the whole northern ridge, and that's about 4 to 4.5 miles long in the entire fuel break. That was completed and pile burned and ready to go. In 2016, we received a 3-year grant. SNC provided a 3-year grant to our partner, El Dorado Irrigation District, for $472,000, and that was to help with cost recovery of completing the prep and the prescribed burn. Up until September of 2019, we had completed about 300 acres, of which we'd spent about $80,000. On September 30th was when the first ignitions started. Some of the things that led to the declaration that I'm going to cover, these are just major themes, but I'm going to keep going. On Monday, September 30th, 25 acres of piles were ignited. There were snow flurries and light rain in the area. As you can see from those pictures, those were actually taken that day. The second picture was taken a day or two later, but there was significant snow on the ground when all the piles were lit. There was expected creep, but it was felt it could be managed. On Tuesday, the hay flat piles crept into some steep terrain up into a brush field where we had planned to do unrestored burning later in the fall. And then the plan for the next day was to continue working on indirect line. This just shows the pile units real quick. If you see the 3 red circles, those were the 3 different areas where piles were lit. The uppermost up here in the northeast corner. In the middle, you see the hay flat, and then down here in the southwest is the Caples trailhead piles that were lit. So on Wednesday, day 2, a type 2 IA crew was requested for additional line work. That was filled with a 10-person fuel crew. The hotshot crew that had originally lit the piles was diverted or was assigned to Colorado for a wildfire. So they took off on Wednesday. On Thursday, after a few days of burning, it was decided that with the complexity of the burn, it needed to be upgraded to a type 2 burn. And it was taken, I took it over as the burn boss. and then started ordering additional resources. On Friday, myself, the Forest Chief 1 and Chief 3, we talked about the situation. We reviewed some fire modeling, and we had full support of the line officers as well as the chief officers on the forest. Friday, our second hotshot crew arrived. They were in briefed and started burning Friday afternoon. And the strategy was to bring fire down the ridge, and eventually the goal was to tie it into Silver Fork Road and basically lock it off. And Friday and Saturday, we had really good firing ops. Saturday night, we sustained our first wind event with 12 to 15 mile-an-hour winds, and it blew it out on top of the ridge, and we were able to pick it up on Sunday, but it took us most of the day. On Monday, the second hotshot crew was pulled for a pre-position assignment and assigned to the southeast, and our third hotshot crew showed up from Southern California. We took a recon that day and observed some pretty major flame lengths in the brush fields, which should not have been expected with the fuel moistures that were measured. We're continued burning towards the 10N30 road above Silver Fork Road. To complicate things a little more, then we had our PSPS shutoffs, as well as the concern over rising costs of the prescribed fire within the grant.
2 minutes.
Thank you. On Wednesday, we got hit with our second wind event, and the fire increased quite a bit Wednesday night. We ended up staffing it Wednesday night and then into Thursday afternoon when the fire was declared. I want to show you here, the dates are wrong. This was from Fire Watch, but the green is what the prescribed fire we had completed up until the 10th. The night of the 9th into the 10th is what the red is. That's how much it grew overnight when we had that major wind event. Some of the major themes that came out, there was incorrect fuel moisture readings that led to some decision making. Burn plans were consistent with agency policies. Trying to get operational tempo with some other things. One of the major resource availability was, we had 5 different burn bosses, 3 different IHC crews. We had limited aircraft and limited resource availability because of due to funding. Something else we identified is the need to order a PIO early and often. We should have ordered one much sooner. And then there's also the stigma of wildfire declaration. Is perception reality putting more people at risk? Hazard pay was a major theme. And what emphasis are we putting on prescribed fire versus suppression for resource ordering? And that's what I've got.
Great, thanks, Travis. This is a great overview of the fire. And we'll be moving into our first section of questions and answers. And thanks for those of you who submitted questions thus far. If anybody else has any additional questions, please type them into the chat box and we'll be going through them. So for our speakers, if you want to start your videos so that we can see you. Our first question is for Becky, and it's from Christina Golitsky. She's asking, is there a correlation between elevation and the difference from normal fire intervals or conditions? And if so, why? Is there less fuel up high?
Yeah, certainly. I alluded to that in my presentation, but so in the lower portion, the western portion of the fire area, that's mostly Sierra mixed conifer. And then at the higher elevations, we're looking more at lodgepole pine and red fir. And so, yeah, there are definitely differences between fire return intervals and those two vegetation types. And it is, elevation driven for sure.
Great, thanks. And for Lester from Stephen Calkins, how far away did you rake or scrape materials away from the trees? a few feet or outside their drip line? And how many trees survived that were treated in this way?
Okay, well, let's see. First, just what the raking. We after a bit of give and take, we were raking out of 2 to 4 feet. Although initially we were looking at going out to the drip line, but that required removing, often it was 30 to 50 feet diameter circle. So it was pretty extensive. It took us half a day to do each tree. And there has been various research done. In fact, Becky had done a great job of synthesizing the information, and there is a document available online that goes through the kind of a decision tree for raking. But the recommendation we had was for 2 to 3 feet, and then trying not to have a big berm of the material that's been raked left there so that it thin it out.
And I can add on just a little bit as far as the other part of that question, which was related to monitoring those trees. I think our intentions were certainly to rake around them and then track them through the prescribed fire. But because we had the wildfire in 2019, there wasn't enough time to actually get out there and implement a good monitoring strategy. However, we are tracking them now currently to look at just not immediate post-fire effects, but also those secondary effects that I think we're really interested in those large trees.
And if I could, there was another question just about the white fir also in the area. And we were focusing on the ponderosa Jeffrey pine primarily. And then, in fact, because the white fir has been coming in because of the shading, so we weren't looking at those, but otherwise trees that had fire scars, we tended to also try and address.
Great, thanks. Another question for you, Lester. Are there similar volunteer efforts going on in advance of other prescribed fires in the region? And also, does this legacy tree preparation typically occur just before a fire, or is there sometimes a lag between the legacy tree preparation and the implementation of a prescribed fire?
Okay, and probably the raking that we did was a little later than it should have been. It's actually recommended and preferred that it be 6 months or more in advance. And we tried to stop by the end of August, just to at least leave a little bit of a buffer. And as far as I know, let's see, there is raking being done in advance of prescribed fire in other situations on the El Dorado forest. I don't know about in other areas, and the raking that's been done has been, I think, primarily with Generation Green, not, we haven't had any volunteer projects. Originally, we intended to have volunteers coming out again in the Caples area when the burning moved over onto the south side of the creek. But with the wildfire, that kind of the whole schedule changed.
Great. So any additional questions, people are welcome to type them into the chat box. And I have a question for Travis here. Has the event affected the forest's ability to implement prescribed fire? Has there been a need for extra communication with the public, especially locally?
Yeah, I talked a little bit about the PIO engagement or PAO engagement, and I think from a burn boss perspective, that's definitely something I should have done better or should have delegated better for public engagement. Has it affected the forest for a prescribed fire program? I think, COVID threw a wrench in that, and we haven't had a lot of opportunities to burn. We've definitely probably taken a little more conservative approach and reevaluated our burn program. We learned a lot from this, and we also made a lot of changes to improve our burn program, I think, for the forest as a whole, to lead to a more successful outcomes.
So can I jump in also? I mean, one of the reasons some of the earlier participants wanted to have volunteers engaged in the prescribed burn was to really start to build a public appreciation for the need for the prescribed burns. And we've, so anyways, that was a message that was carried quite a bit. And we also actually used some of the grant funds to design and purchase a sign that hopefully will be able to, we got caught by early snows, but put out so that people appreciate that come in and hike in the area, appreciate the value of the burn in the area, that they should view it as a positive, not a negative.
Great. Our next question, which I think a couple of you might be able to answer, is what are some ways to evaluate legacy trees when some may actually be contributing to the fuel loading and should be removed? Perhaps not all large trees need to be left since we have changed natural fire return intervals so drastically. I don't know, Becky, you want to take a stab at that?
Yeah, that's an interesting question that I know we're grappling with in other restoration projects where we have more mechanical treatments available to us. I think in the context of the Caples restoration project, there wasn't any intention on ever targeting any of the larger trees for, if they were impacted by the fire. However, as we track large trees, I mean, I think we're likely to see some of them die or succumb to secondary mortality effects. So, like insects or things like that, or maybe prior damage from the fire that makes them more susceptible. And I think the other really big concern now, I think in my mind, is drought. So, I think the winter started out really good. And I think my thought was, well, it's great for the trees. But I think the early spring may present sort of a second stressor on a lot of those trees that may have already been stressed by the fire. I'm sorry, I'm not sure if that answered the question necessarily. I mean, I think because of the way this restoration project was, focused mostly on prescribed fire, there really isn't an opportunity to, target specific trees, but I'm sure we'll see some changes in those size distributions.
Mm-hmm. Thanks. Our next question is for Travis from Jane Braxton Little. Could you be more specific about how you changed the prescribed burn program post Caples?
Well, I don't think I personally changed the prescribed fire program. I think what came out of the prescribed fire review is things we needed to change as a whole district as well as forest wide. There was changes to our processes, some notification processes we needed to change, as well as amend some of our burn plans to make them a little tighter. And I could get into some deep into the process, but I don't think we really have the time today to talk about some of that stuff.
Okay, thanks. And then from Karen Leese, what were the considerations of burning in the spring versus the fall?
So I know from a burn boss perspective, we take that very seriously. Some of the considerations we are concerned with burning in the spring is when the trees are, and Becky can probably speak more to this from an ecological perspective, but when they start to, flush, we need to be real careful at our timing of the prescribed fire in the spring so we don't kill them. It's much easier burning in the fall when they're starting to, ramp down and go into their dormant winter mode. And it is a little easier burning with dry conditions in the fall.
Great. Well, we are at our break time now. I do see your question, Autumn, and I believe that one of our next speakers is going to get into that. And so if your question is left unanswered after the next set of presentations, please let us know, Autumn. So thanks for those questions so far. And please, if you have additional questions, we'll continue to keep track of them for our next Q&A session. I'm going to pass the mic over to Becky, who's going to introduce this video and photo montage, but we'll be taking about a 10-minute break. We'll come back at 2 p.m. And during that break, this video will be playing.
Yeah, so we really thought it would be a good idea to try and share some video footage from the Caples landscape. And we're lucky enough to have some amazing footage of the 2019 post-fire Caples landscape that was shared with us. So really, you know, if you could sit back, drink your coffee, stand up, stretch, enjoy the flight. I think Travis had some really great footage in his presentation that I think will make a lot more sense looking at this video footage. And along the way, we will land on the ground and look at some specific post-fire outcomes. And I will say, if you're interested in any of this footage or photos, please contact me.
What was happening in this landscape post-fire? So you've already seen some of the maps of the Caples Creek watershed, so you're pretty familiar with the location. But just as a reminder, here's the location of where the drone took off. So it was just off Highway 88, near Martin Meadows. So that gives you sort of an idea of where we're going to be. So we're going to be looking at mostly down canyon, so to the southwest. Okay, so the drone's going to take off. It takes a little bit of time to move around. So we have to be patient both with the speaker, and then we have some sections in here where we're going to break out into some stills that we can then look at together and talk about some of the effects. So as the drone takes off, the first thing, so if you think about Highway 88, we're on the north side of Highway 88 near Martin Meadows. So like Kirkwood Inn side, you know, across from all the lakes. So across from Caples Lake and Silver Lake. And we are sort of looking right now, this is a little bit to the north, across from the north side of the canyon to the south side of the canyon to the north side. And so you can already start to see some of the fire effects as we move through here. You know, one thing that you notice is there's a lot of area where it did burn very hot. You can see those south-facing slopes across the canyon here. So those were all chaparral dominated. And if you remember, we talked a lot about fire severity, and you would expect fire to consume those shrubs. Now, it is interesting to note that there are some cases where it didn't consume all the shrubs. But those are pretty much all along the ridgeline. And then you'll also, I think, notice there's a lot of granite in this landscape. And if folks have ever been on the Caples Creek Trail, directly ahead of us, those two meadows right there. So that is I believe the Government Meadow complex. Right now I'm sort of failing. Yes, Government Meadow. I don't think we've taken our turn towards Jake Schneider. Okay, so granitic areas. So I thought it would be really neat just to look at some stills. So these are photos that we took at the monitoring points that we have stratified throughout this landscape. And so this is a pre-photo, and so you can see how open these conditions are. There's just these really large openings of granite. I actually think on this plot and this day in particular, while we were reading the plot, a critter came out and chewed the tape in half, and we couldn't figure out what was happening, why the tape was loose. So here's a post-treatment picture, and I apologize, these photos are a bit pixelated, but you can definitely see the difference in these granitic areas. So the granitic areas, you know, we saw some mortality, but it really helped to decrease fire behavior across this fire. So it helped to regulate it. And I think I mentioned before, that's what made it sort of a prime candidate for restoration with using fire only as a tool. Here's another example of a post-fire landscape where it was very granitic. You can see that there's still a lot of green trees. It definitely affected some of the understory in some cases where we had continuous fuels. Okay, so we're taking off again. And I'm going to be quiet for a moment and just let you watch. So this gives you a really good look at the chaparral dominated areas. So this is an example of one of the plots that was in chaparral areas, and you can see it's pretty dense. I know there was one monitoring plot that we had in the chaparral that took us like, I don't know, 2 hours to get to because it was really hard to walk through. So this is Manzanita. And there are a number of areas throughout the Caples project where we had chaparral. So this is an example of the post-treatment in chaparral. So this is the same plot location. You can see that most of the chaparral has been consumed. So once again, we're going to start moving here, and I'm just going to let you guys watch. So you see we're panning around here to more of that south-facing canyon. And then now you can see Jake Schneider in the distance there, the green spot. So, and I think it's also interesting to note that in the distance you can also see, well, we'll talk about legacy trees, and then I'll get back to the photo. So I talked a little bit about the legacy tree work. So we had volunteer efforts out here to rake around the large trees. Obviously the photos aren't going to do these justice. I think I may have some photos with people in them here so that you can really see how large these trees are. And so I think one thing to note is that these trees have been here, you know, prior to fire suppression. We didn't actually age of any of them, but I'd be willing to bet they're 300 to 350 years old. And in that previous photo, you could see how there's a lot of trees surrounding these older trees, and those have all come in that period of fire exclusion. So we had quite the volunteer effort out here, and the plan really. Oh, and I remembered I was going to mention, so off in the distance, you can see there's those openings, those patches, and those are, so a lot of this project area is surrounded by other private industrial lands, and so those are some of their treatments. And that is one of the reasons why this project was a bit more complicated. You know, we didn't want to have any impact on the surrounding landscape. So once again, just for a reference point, that's Jake Schneider Meadow, that green spot. And you can see sort of in the right-hand corner there on the ridge, it's pretty steep. It's hard to really understand how steep that slope is, but you can see some really cool geologic features, some Devil's Postpile type features there on the right. Really, really interesting.
Great. Welcome back to the webinar. And thanks to Becky and Stacy for putting that little video and photo montage together. We'll be posting that to the website, and it's about 16 minutes long in its entirety. So if you're interested in seeing more of the visuals, you'll be able to check that out at a later time. So our next speaker is Scott Dailey. Scott is a fire ecologist with the U.S. Forest Service Enterprise Program. He's done work associated with the Fire Behavior Assessment Team, or FBAT team, since 2003. Today, Scott will be telling us about the first order fire effects on the Caples fire. So Scott, when you're ready, you can go ahead and start sharing your screen. There we go, looks right.
How's that? Did that
Looks
work?
correct, yep.
All right, great. Thanks, everybody. All right. Sorry for the technical difficulties earlier. So good afternoon, everyone, and thanks for having me here today. So I'll be sharing the results of first order fire effects of the Caples fire that were collected and analyzed by the Fire Behavior Assessment Team. In late October 2019, after the Caples fire had been contained but not controlled, FBAT was asked to capture the immediate fire effects of the fire, the first order fire effects. There was great interest in getting a quick, rough estimate of the results of the prescribed burn and associated wildfire. The objective for collecting first order fire effects at Caples was to provide a quantitative snapshot of the immediate results from the fire. The analysis was intended to help serve as a baseline to improve the understanding of changes that will continue to settle in post-fire. Work remains to complete the Caples Creek restoration project. It's expected that these results will help inform ongoing decisions to improve and maintain ecological conditions there. So to determine if management objectives were met, we focused on the key question: how well did the Caples fire move conditions towards a more natural, resilient ecological state? To answer this question, we looked at changes in tree density, related to levels of tree mortality. And then data was collected on various burn severity metrics in order to define immediate burn severity as a gauge for meeting ecological goals. We also gathered data on fuel consumption to gauge how well the fire met hazardous fuel reduction targets. So planning for the data collection occurred very quickly within 1 week. We had to move fast. The game plan was made with a lot of collaboration with staff from the R5 Ecology program and the El Dorado National Forest. The data was collected by FBAT with a field crew of 6 during the first 2 weeks of November 2019. So we collected data on 46 pre-established monitoring plots that fell within the footprint of the Caples fire. 38 of those plots were in forested vegetation and 8 were in chaparral. Our data collection methods were based on a modified version of the protocol that had been used by the R5 Ecology program to collect pre-treatment data at Caples from 2013 to 2018. Those same plots that Becky talked about already. Data collection included taking post-burn photos to match with pre-burn photos. And then for fuels data, within each plot, we collected standard data on fuel conditions to capture changes in fuel load for both ground and surface fuels. For fire effects on trees, live status was collected along with burn severity measures of char, scorch, and torch heights. And then for substrate and understory vegetation, the standard 5-point burn severity rating system developed by the Park Service was used to define burn severity. Okay, so the analysis was kept fairly simple. We just used basic descriptive statistical analysis. It was performed on the data to create mean values on a per plot basis. The goal was to provide quick and straightforward information on the immediate change in condition resulting from the fire. Data was stratified to compare fire effects by general ecotype, so forest versus chaparral, and by fire type for the area that burned under prescribed burn versus wildfire. And getting to results. So starting with burn severity, this slide shows the burn severity distribution for substrate, which includes soils, litter, and duff. On the left side, you see elevated levels of high burn severity for substrate in the forested plots compared to the shrub plots, which are on the right. The greater amount of high burn severity for substrate in forested plots is assumed to be tied to the heavy fuel accumulations which occurred in forested areas with over a century of effective fire suppression that was discussed already. This slide shows burn severity for understory vegetation. Forested plots are on the left with shrub plots on the right. For clarity, understory vegetation included all vegetation except for trees greater than 3 inches DBH. Here we see greater amounts of combined high and very high burn severity in chaparral areas compared to forested areas. This was visually evident for those visiting Caples burn area immediately following the fire. I think we saw a lot of that in the video that Becky shared in some of the photos. So here we see burn severity for smaller intermediate sized trees on the left. These are 3 to 12 inch DBH, and larger sized trees, those greater than 12 inches DBH on the right. The difference is subtle, but we found more low severity in the larger trees, which was an objective of the project. So this slide shows overall burn severity, which is based on a compilation of all burn severity components, including burn severity for substrate, understory vegetation, and trees all combined together. Here we see the difference of overall burn severity for forest plots on the left compared to shrub plots in the center, which shows a much greater fraction of high burn severity. On the far right is burn severity across the entire burn area with forest and shrub plots combined. Because shrub plots accounted for less than 20% of the fire area, its impact on overall burn severity fraction for the entire fire area is limited. So there was great interest in determining differences in fire effects for the area burned as prescribed fire versus the area burned as wildfire. Using the fire progression map, we stratified the plots as either prescribed burn or wildfire. In this map, it shows the prescribed burn area in yellow. This area burned from September 30th through October 9th. The remaining area was burned by the wildfire, which was declared on October 10th. Okay, so this slide shows us the difference in overall burn severity fraction for the prescribed burn area on the left compared to the wildfire area on the right. First, we see a greater fraction of low burn severity for the prescribed fire area. It's interesting that the prescribed burn area has a slightly higher percentage of high burn severity than the wildfire portion. That's kind of unexpected, but it's suspected that the higher percentage of high burn severity in the prescribed burn area might be related to more adjacency to shrub areas, which tended to burn with greater intensity. Also, it's important to consider that tree density was considerably higher in the prescribed burn area, which was 253 trees per acre, compared to the wildfire area, which had 194 trees per acre. So that may have come into play as well. So to help gauge whether or not the Caples fire burn severity fraction met ecological goals, we compared the results of the burn severity of the Caples to burn severity fraction found in studies of past natural wildfires that have occurred across the Sierra Nevada under limited or no suppression action. These fires were shown to be representative of the natural range of variability, or NRV. The first column on the left, it shows the Caples burn severity. And the second and third columns here showed the results of studies of resource benefit fires in Yosemite, and then Yosemite and Kings Canyon combined. And the last set of data here is for fires allowed to burn in wilderness areas on Forest Service lands in the Southern Sierras. So the similarities here are pretty striking, and it shows that according to burn severity fraction, the prescribed fire portion of the Caples fire was very similar to what is found with past wildfires in the Sierras that can be considered more natural. In this slide, burn severity fraction for the wildfire portion of the Caples fires compared to results of studies reporting burn severity fraction of various suppression wildfires across California. For a local comparison, we included the King Fire, which is shown on the far right, which we'll discuss more in a minute. Here we see less severe fire effects in the wildfire portion of the Caples fire compared to other suppression fires in similar ecotypes. Furthermore, the wildfire portion of the Caples fire was not all that different than the resource benefit fires displayed previously. So there was great concern about the high potential for a stand replacing fire event in the Caples Creek watershed. Looking at the King Fire, which occurred on the El Dorado National Forest in 2014, it provides a reasonable example of how severe a fire could have been at Caples. The King Fire occurred at about the same time of year in September across similar elevation ranges, with similar topography and with similar vegetation and fuel types. Notably, the King Fire occurred in the midst of a severe drought, while the Caples Fire occurred on the heels of that drought. Also worth noting is that suppression resources were established on site at the time of the Caples, the Caples Fire became a wildfire. So looking again at the burn severity fraction of the Caples Fire versus King Fire, the area which burned as wildfire in the Caples Fire resulted in less severe fire effects with 7% high burn severity compared to the King Fire, which resulted in 53% high burn severity. Okay, so there's a lot going on here in this slide. So let me explain the layout before diving in. This slide shows a comparison of how prescribed fire and wildfire reduced trees in different size classes compared to tree densities determined to be the historical natural range of variability for this area. So prescribed fires on the left and wildfires on the right. Tree size classes are shown on the x-axis on each graph, with smallest trees on the left moving to the largest trees on the right. Tree density is on the y-axis. The gray bars show pre-fire tree density, and post-fire tree density is shown with the blue bars for prescribed fire and the purple bars for wildfire. Natural range of variability is displayed with the black markers. Mean NRV is shown with the square, and the plus and minus symbols display the range of NRV for each tree size class. So first, looking at smaller size trees, those in the 3 to 8 and 8 to 16-inch dBH classes, the pre-fire tree density shown with the gray bars indicate just how high tree density levels were pre-fire, well above the mean NRV. And in most cases, it was well outside the maximum historic NRV. Next, see that post-fire in prescribed burn areas, tree density remains above the range of NRV for smaller trees, and wildfire effectively reduced the density of smaller trees to a level close to mean NRV. Here we see that for the Caples fire, the wildfire portion produced more beneficial results for small trees than the prescribed fire portion. That said, it's understood that the intent is to return soon with additional rounds of understory burning to further reduce those small diameter trees in those areas where it's needed. For mid-sized trees in the 16 to 24-inch dBH range, pre-fire tree density was within the historic NRV. Prescribed fire on the left did a good job of bringing tree density very close to the mean historic NRV, and wildfire reduced trees to a point where they dropped below the NRV. Moving on to the largest trees, pre-fire tree density for trees in the 24 to 31-inch range was below the historic NRV in both the prescribed fire and wildfire portions of the Caples fire area. This shows why it was important to minimize loss of these larger sized trees. Pre-fire, the largest trees greater than 31 inches were within the NRV, but below the mean NRV. Post-fire measurements showed that tree loss was successfully limited overall for these largest trees, with better results in the prescribed fire than the wildfire area. The Caples prescribed burn plan set an objective to limit the mortality of legacy trees greater than 30 inches to no more than 5%. Our sampling showed 0 tree mortality for trees greater than 30 inches in the prescribed burn. In the wildfire area, tree mortality was 23%. Okay, so let's take a look at surface fuel reduction. This slide shows us pre versus post-fire surface fuel load of smaller size fuels, those up to 3 inches diameter, compared to the mean historic NRV. The light green bars represent pre-fire fuel load, and the darker green is post-fire fuel load. The black bar shows mean NRV. We see that both prescribed fire on the left and wildfire on the right brought fuel load closer to mean historic NRV. Prescribed fire did a slightly better job.
2 minutes.
Okay. For larger size fuels, those greater than 3 inches diameter, both prescribed fire and wildfire brought the fuel load substantially closer to the mean historic NRV. In the wildfire portion of the fire, coarse fuels were brought closer to mean NRV. Okay, and so let's take a look at ground fuels, litter and duff. So the mean NRV for combined litter and duff depth is determined to be 0.6 inches. Pre-fire at Caples, this depth was 2.2 inches, which is 267% above the mean NRV. Post-fire mean litter and duff depths were measured at 0.2 inches, which is 67% below NRV. So the fire did bring ground fuels closer to NRV. Lastly is shrub cover reduction. The shrub cover reduction target was set at 70% in the Caples burn plan. Shrub cover reduction was measured at 73%. So came very close to meeting that objective with the fire. All right, so the take-home message. According to our findings, both the prescribed fire and wildfire portions of the Caples fire were mostly effective in meeting project objectives to move the Caples Creek watershed towards improved ecological health. More robust studies on the fire effects are ongoing, but it's expected this information will help to provide meaningful context to the changes that have yet to settle into place. We hope this information will assist land managers in their continued efforts at Caples.
Great, thank you, Scott. I'm glad that we got your presentation working. Really interesting to hear about all that work. Durrell is a senior research fellow at the California Academy of Sciences, where his lab applies transdisciplinary science to solve problems ranging from conservation and emerging infectious diseases to forest resilience in a changing climate. Each spring, Durrell visits California's Sierra Nevada mixed conifer forest to work on the resilience of forests and their bird communities in collaboration with the Academy ornithologist Jack Dumbacher, conservation biologist Pat Manley of the U.S. Forest Service Pacific Southwest Research Station, and a growing team of researchers, students, and community volunteers. So Durrell will be telling us about the avian response to ecological restoration in the Caples Creek watershed. Go ahead.
Thank you so much. I'm really happy to be here to represent our team, and I'll cover the team in just a second. First off, a quick caveat. We are in the middle of measuring the post-fire response of the bird community at Caples Creek. But we're really interested in is the understanding what really is resilience. And we've been working on this with the Forest Service since 2015. So remember, everything today is preliminary, and we're actually going to show you, which is easier to interpret, sort of our raw data. So that's pretty exciting. So let me just see if I can get the next slide. So here's the team. Of course, partners in crime, Pat Manley and Angela from the PSW, Forest Service, and then Becky at Region 5, and all the people in the El Dorado who are our hosts and make it possible for us to do this work. This is seasonal work, so we show up in late May and we spend a few weeks, usually 3 to 3.5 weeks, measuring the bird community. The Academy folks, you can see there, myself, Jack Dumbacher, who's our ornithologist and mammologist. We have one of our geologists working on the deep thinking about this problem, Peter Rupnerine. Mary Clapp, who's in the middle left, is actually really critical for this study. She's been working with the acoustic data. And then we have a larger team that includes Google, and we get interns from the National Science Foundation. So I got to thank everybody. So really quickly, what is the big picture? We're really interested in the interaction between fire, all the biodiverse forest denizens, and this concept of resilience. What we'd really like to do, or we would really like to have, is a forest that was resilient to various disturbances. So what do we mean by that? So this is the intersection of these three diversities today are pretty important. So resilience is the ability of any system to respond to a change or disturbance and be somewhat similar afterwards. In other words, maintain a structure, a function, and look similar. So a forest would remain a forest. And as a conservation biologist or a systems person would believe that this is conferred by various things, such as fire. For instance, on the upper slide, you can see part of the post-fire area on the side above Hayflat, where we just heard about the initial work for fire breaks on the Caples area, but also a place that has a lot of fuel buildup and no natural fire could be less resilient. And you can see that in the lower area, there's a lot of fuel buildup there. So we also have other disturbances that we want to worry about, such as pests, but we won't talk about that today. So a couple of key questions for today that our study's working on that we won't get all the answers to, but how does fire affect those three components of biodiversity for forests? And then how does the effort to manage for resilience impact things that we can measure, like bird diversity? And in this case, we have the fire acting at Caples, but we're also working with Pat on her large scale studies across the region that include mechanical thinning. And so one of the quick ideas is that we want to know how well does biodiversity act as a measure of forest health. But if we think deeply about the whole issue, biodiversity is actually contributing to the future resilience or the ongoing resilience of a forest. So it's an interesting conceptual place to be working. Well, let's get down to brass tacks. What do we do? Since 2017, our team has gone out to work across the area that was planned to be, had a application of prescribed fire. And we basically surveyed 82 points that are 400 meters apart across the landscape. Many of these same points Becky just described measuring vegetation at. So we got to survey the birds over 3 years in the spring before the 2019 fall Caples fire. And we've just gotten 1 year past the fire where we had spring 2020 doing a COVID safe field trip to spring the post-fire effects. So here's our sort of effort really quickly. Before, we basically measured our 80 to 82 points 3 times per season. And we stood there for 10 minutes and counted birds, really basic methodology. We also, starting in 2018, deployed some recording units, which we won't discuss today, except for that they're super helpful for trying to fill in some of our more difficult to detect species. And then we had the planned and also the realized experimental design. So essentially, as Becky already showed, we have low, moderate to high, and high intensity fire. And that's the distribution across our points. So the first thing we notice is that no matter how we measured it, the species richness went up after the fire. And this is a well-known thing at the landscape level, where we basically say diversity of fire or pyrodiversity increases the diversity of birds. So that's the basic start of the story. And I'm going to go straight to using just the number of points on our study area that were where we detected the birds for before and after the fire as our main measure. And that's called the naive occupancy. This is kind of a hard graph to get over. But basically, if you look on the y-axis, we measure the difference between the average of the before in naive occupancy and the post-fire, where we only have one data point right now. We can organize the birds from the ones that were most increased, those are on the left, to those that had a small decrease on the right. And that's all I'm going to talk about today. Let's go into those, dive deep and get away from these 4-letter codes. So let's start with the species that increased outside of the range that we measured over the previous 3 years. So the number of survey points where they were detected went up beyond the maximum that we'd previously measured. And I'm just going to highlight a few. If you look at the bold-faced species, we see a canopy species, a hermit warbler, a common species that likes open areas but nests in the trees, American robin, mountain quails, which is pretty variable, but did just make it above that historic variation, hairy woodpecker, red-breasted sapsucker, a warbler that likes the understory, olive-sided flycatchers, which we almost all know love to feed from very high perches, and 2 species that are fire adapted, both the blackback woodpecker, which had not been previously seen on the points and saw it was seen at 10 points. So that's a big change. And red crossbill, which is nomadic and was seen only after the fire, never actually perching on a point when we were measuring it, but we did see them perching and feeding across the fire area. So that's naive occupancy, a large change. There's some that were sort of in a small change, like above 3 and below 8, and but they were still outside that previous variation. These might not be in any way biologically out of the range that we normally look at, and there's some of our most common species. And even I just want to point out a couple of rare species on the study side on the right, included a huge number of turkey vultures detections that, of course, they're not perched on the landscape, but they were more common than we'd seen them in the previous several years, which is really interesting. There's a species that did not change. So the ones that were no lower or no higher than 3 survey points, and they overlap the pre-fire variation. And that's just a wide range of species. Many of them, like the golden crowned kinglet, prefer the conifers, and some of them are in the scrubby vegetation like the house wren, and they're not very common. So there's a whole range of species that were not affected that we can tell in terms of their spatial distribution or occupancy. There may have been few species that went down, and this is a very short list, and I'm saying may have because, for instance,
2 minutes.
2 minutes, that's fine. Hermit thrush is essentially a water-loving species. They went down about 4, and pileated woodpecker went down about 5.5 points from the before average. These other two are interesting. It's just that they're rare enough on the study site that if they've changed at all, they may just be gone or nearly gone. So what do we have? We have those 2 species that I just mentioned, basically almost the only things on the whole study area that may have decreased in occupancy. Many species that are fire adapted increase in occupancy, and others that are just that were already there did well. So what we really need to know here is that this is early days. I showed you no statistics yet because we don't have post data. So the next step is to do a couple more years of surveying starting this spring. We have to model the occupancy in order to take into account detection probability. And then we can do a formal test using that amazing before, after control and impact design we get from the Caples fire. With the help of Google, we're working on acoustic data. In order to scale this up to the landscape, we have new funding from the Wildlife Conservation Board, and I want to talk to anybody later about that. But essentially, we can't really know what's going on at the scale of watersheds or beyond unless we understand what the birds are eating or the other species are doing there. So more on that. And I just want to thank everybody. It's an amazing team to work with. And I just want to mention Angela White. She doesn't like her photo taken, so there's her picture represented by the Western Tanager. So she's been helping with Mary's and doing the occupancy modeling. So thanks to everybody. This is awesome opportunity to work in the El Dorado National Forest on this project.
We're going to circle back now to Becky Estes, who will be giving us our final presentation, and we'll recap what we've learned today and bring us back to the big picture around restorative burning and prescribed fire use.
Alrighty, so hopefully everybody can see the presentation.
Looks good.
And hear me, okay. Okay, excellent. Well, I really appreciate all of the excellent speakers we had today. And I realized that we were just able to scratch the surface in our discussions of the 2019 Caples fire and its implications within the landscape and on other large landscape scale restoration projects, particularly those where prescribed fire is a major focus. Hopefully in the future, we'll be able to do a field tour into the 2019 Caples fire so we can further some of the discussions that we've had today. So I just want to sort of bring everything back together and think about sort of big picture and ask a couple of questions that I think are running through my mind about how we can utilize the information that we're gathering within the Caples fire to help us not only plan large landscape scale projects, but implement them across the Sierra Nevada. So I think most of us know it's widely agreed upon that Sierra Nevada forests are fire adapted ecosystems and that fire is an essential ecological process that operates at much larger scales than we often plan at. Fire promotes ecosystem function, health, and resilience. Fire promotes fuel reduction, spatial variation and structure, and composition, as alluded to in Scott's presentation, and increases biodiversity, as Durrell talked about, as well as other aspects such as regeneration, floristics response, things like that that we will continue to track moving forward in this landscape, as well as the impacts on the legacy trees. So we also know, and I pointed out at the beginning of the presentation, that fire exclusion or the removal of fire as a natural ecological process has created a loss of forest ecosystem integrity, which all the speakers today recognized and alluded to. This has caused an increase in densification, homogenization, and a reduction in health, resilience, and diversity. And so Scott really highlighted in the second half of this webinar how we know that these changes have occurred in the landscape and sort of where we're going following the 2019 Caples fire. And I will just point out here, the 2 image panels is another really good way to look at how things have changed in this landscape. So on the left-hand side, we have a historic photo from 1899. And on the right-hand side, we have a photo pre-fire and from 2014. And so we can really look at these successive photo sets to understand how changes are occurring across this landscape. And I will point out, this is the upper portion of the watershed, so that eastern portion that I talked about earlier and you saw in some of the virtual footage. So we've implemented restoration across this landscape, treatments that we're hoping are reestablishing forest ecosystem structure, composition, and function. And this is happening by the reduction in stand densities and biomass, which Scott pointed out, restoring structural heterogeneity, improving health, resilience, and diversity with Durrell, which Durrell has talked about. And so we're really hoping to get to this point, and these two slides on the bottom here, these two images, where we have the sort of landscape where fire has been excluded, and we're able to restore it to a landscape where fire can move through it and not cause deleterious effects. So did the 2019 Caples fire have beneficial restoration treatments? So the fire didn't occur as planned in well-designed units over a 10 to 15 year window, but rather in one fire. But I think from the talks that we've heard today, at least initially, the answer is yes. The fire did shift structure and composition of certain forest structure and composition metrics closer to NRV for the Sierra Nevada mixed conifer forests within this landscape. With that being said, there will be continuing work monitoring all of these aspects to really capture those secondary post-fire effects that we might be seeing in the future. So I think the one thing that I keep asking myself is what fire effects are desirable. We know that when we shift from prescribed fire to wildfire, although a lot of Scott's results are showing us that there wasn't a lot of difference between those two, oftentimes when we have wildfire, there is the possibility to have consequences on this landscape that really beg the question of what fire effects are desirable. In prescribed fire, we typically see this similar to this upper left-hand panel where we have effects on the understory, maybe we affect some of the midstory. Typically our intensities are low and severity is low. So we're not really changing the density of these forests. And as we've seen in certain circumstances, the density of the forest really need to change. In a lot of landscapes, we can use mechanical treatments as a means to get to that reduction in forest density. In the case of the Caples fire, that wasn't an option and is likely to be the case in other landscapes where, for whatever reason, mechanical treatments aren't a viable solution. And so at what level really are we increasing the resilience of this landscape? If we look at the, if we transition to wildfire and think about the consequences from that, in this lower right-hand panel, sometimes we see areas that have been impacted where it's 100% mortality, we no longer have any seed source, and the likelihood of trees being present on that landscape are probably zero in any foreseeable time in the future. So that may not be an outcome or that we want to see from our fire. So it's somewhere in this sort of middle ground. And I really like to think that maybe there isn't one right answer, but we rather focus on a range of conditions within these large landscapes as far as fire effects go. And one of the other things I've been trying to think about is, so how can we achieve what we did inadvertently in the 2019 Caples fire across other landscapes? And so one of the things that's been running through my mind, I pulled this table from a recent publication by Hires et al. And it was just looking at different factors and how we plan for them in wildfire and prescribed fire. And the benefits of planning a prescribed fire is that, we do this over weeks to years, multiple years to decades. It typically doesn't happen at the same scale as wildfire. And I think I mentioned that earlier, that when we have a wildfire, it typically can be, thousands of acres, thousands of hectares, whereas prescribed fire is typically planned on a much smaller scale. But the other benefit to prescribed fire is that we can really focus on meeting our resource objectives. And you've learned a lot about that today on how we used empirical data to help inform our targets, and then we evaluated those And we were really able to do that because we had the time to develop a monitoring network within this landscape. And then there's other aspects of prescribed fire that differ from wildfire as far as study designs and experimental research. And we've really been able to capitalize on a lot of that because of the planning that went into the prescribed fire. And so for me, I really think about the use of the prescribed fire tools that we have available to us to help us plan our landscape scale burns and implement all of the components that help reinforce the anticipated outcomes in that target landscape. And some of these things are reinforcing fire breaks and barriers, whether they're natural or man-made, reducing fuels, preparing large legacy trees, as well as other activities. And then be sure to evaluate opportunities. So, and what I mean by that is in certain circumstances, maybe not so within the El Dorado National Forest Plan, but on other forests, they may have the ability to manage lightning ignitions. And if you already have your large landscape prescribed fire plan in place and you feel like everything is reinforced, then you might have some opportunities to manage a lightning ignition in these landscapes in conjunction with the prescribed fire. And so I really think that, that gives us the opportunity to increase the pace and scale across these landscapes. So those are kind of two questions that I leave people with is, just what is an acceptable range of fire effects across these landscapes? And do we feel like the 2019 Caples fire met that acceptable range? And then how can we achieve a similar approach or success or outcomes that we did in the 2019 Caples fire across other landscapes in the Sierra Nevada? And that is what I will leave you with today. And we're